Hi, this is Divya, Assistant Professor Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the continuation of the previous video, that is the types of a semiconductor. This is an intrinsic semiconductor. Intrinsic semiconductor, as I told you already, it is a pure form of a semiconductor material where we have the silicon and the germanium. Germanium and silicon are the pure form of semiconductors where we need not have any impurities to be added to it. Okay. Here we can see that the silicon have the free electrons and its corresponding holes. Okay, and a broken covalent bonds. Okay, the bonds gets broke and it gets connected to another electrons or holes in the next silicon where we have. See, one silicon component is covered with 4 holes. Okay, 4 holes where we have electrons in it also. Okay, we have equal number of electrons and holes which is together to form an intrinsic semiconductor, as we told already, right? We have 4 holes and 4 electrons which is surrounded along with the silicon material. Once gets attracted, holes in the electrons and holes gets attracted to each other, and then there gets a covalent bond. Okay, the blue color indication will shows the holes and the yellow color indication shows the electrons, and the green color, right, green color arrow mark directs the electron movement, and the yellow color direction shows the hole movement, how the holes gets moved to another next covalent bond, and how the electrons moves towards the holes. Okay, and next, the intrinsic type of semiconductor material is made to be very pure chemically. As I told you, this is a very pure form of semiconductor material, so it is a very pure chemical. Germanium and silicon are the most common type of intrinsic semiconductor elements. Okay, germanium and silicon are most common type of semiconductor materials, as I told you. They have 4 valence electrons, that is tetravalent, as I told you. They have 4 valence electrons which is surrounded around it. They are bound to the atoms by covalent bond at absolute zero temperature. They will have a absolute zero temperature to form a covalent bond. Okay, as I told you already, the valence electrons, they have 4 valence electrons and they are bound to atoms. Okay, by covalent bond, which is absolute, which is to be measured at an absolute zero temperature. Okay, this A and B diagram shows that the valence band and the conduction band. Okay, we have an energy gap between. We have 4 valence electrons in the which is surrounded along the silicon material. Okay, next is the extrinsic semiconductor, where I told you already the impurities to be added to form a pure semiconductor. Okay, N type and a P type semiconductor. N type, as I told you already, where electrons will be higher than the holes, where in P type the holes will be greater than the electrons. So P type is called acceptor impurity, whereas the N type is called donor impurity, where the holes is higher, right? It will donate the holes to another electron. Okay, whereas in the P type the holes gets attracted, that accepts electrons. Electron hole recombination is the process, right? So the N type impurity, N type material will have a donor impurity which donates the free electrons, and here it acceptor impurity where it accepts the holes. Okay, next is N type semiconductor, which is mainly due to electrons. As I told you, it is mainly due to electrons. Entirely neutral. This N type semiconductor is an entirely neutral one. Majority electrons, Minority is holes. As I told you already, majority electrons is greater than the holes. When a pure semiconductor, that is germanium or a silicon, is doped by pentavalent impurities, then 4 electrons out of 5 valence electrons bound with the 4 electrons of germanium or silicon. Okay, the germanium or silicon will have a 4 valence electrons, and that will be added, the 4 valence electrons will be added with a pentavalent impurity. A doping impurity will be added to it. Again it will get a 5 valence electrons bounded to form a 4 electrons of germanium and silicon. Okay, already we have a pure form of semiconductor that will be added to an impurity, added by an impurity atoms, pentavalent impurity atoms. In that, the pentavalent impurity atoms will have a 5 valence electron, and here it is 4. This combined together will form a 4 electrons of germanium or silicon. Thus, the impurity atoms donates the free electrons for conduction in a lattice, and it is called a donor. Okay, thus the impurity atoms donates a free electrons for conduction in a lattice is called donor. As conduction is due to the large number of free electrons, the electrons in the n-type semiconductor are the majority carriers and the holes are the minority carriers. As I told you already, the majority electrons and the minority holes. Here the electrons in n-type semiconductor, majority carrier will be of electrons will be of majority carriers, and the minority carriers will be of holes. Okay. Next is a p-type semiconductor, mainly due to holes. N-type semiconductor, as I told you already, it is based on the electrons. It is the n-type semiconductor. P-type semiconductor is based on holes. This is also entirely neutral. Okay, where the holes and electron recombination occurs, no, there will have a neutral charges only. Majority holes and a minority carrier. Just opposite to the p-type is an n-type. When a pure semiconductor is doped with trivalent impurities, the 3 valence electrons of impurity bond with 3 of 4 valence electrons of a semiconductor. This tri is 3 valence electrons will be bounded with the 4 electrons, which together to form a semiconductor material. Okay. These impurity atoms which are ready to accept bonded electrons are called acceptors. There in lattice they are called donors. Here accepts bonded electrons, they are called acceptors. As semiconductor is due to a large number of free holes. The holes in the p-type semiconductor are the majority carriers and the electrons are the minority carriers, which is just opposite to the p-type n-type material. There the holes are minority carriers and the electrons are majority carriers. Here the holes are majority carriers and the electrons are minority carriers. These are the types of the semiconductor materials where we are going to know what are the semiconductor material and the type of semiconductor materials. Thank you.